Besides curves directed to the left or right, there are also the movement going up or down. Learn about vertical alignment here in engineering surveys. A natural grade line can also go up or down, and in case a highway or road is to be constructed, engineers need to design the curves. Straight lines in highway engineering are also called as tangents. So in the profile, we have an ascending first tangent, followed by the second tangent directed downwards, and also another ascending tangent 3. In the illustration, we have a rising up curve 1, followed by a going down curve 2. Gradient or grade is a term we use to define the slope of a tangent. This is like rise all over run, which can also be equated as tangent of alpha. In highways, saying that we have a curve, the first gradient rises up, and it is called positive P. Then the other tangent, which goes down, is called negative Q. In other references, instead of using P, they use G1 in small and capital letters. Q is also written as G2 in both small and capital letters. Next is the signs before P and Q. A positive prefix means ascending or rising up, and a negative sign is descending or sliding down. Although gradient is dimensionless, we can write it like positive 4%, for example. This means that the road rises 4 units vertically in 100 horizontal units. If written mathematically, this is like 4 out of 100, which is then simplified as 0.04. Since this is analogous to slope, we can also refer gradient as the change of y with respect to x as 0.04. Another way to write the gradient is to place it as 1 in 25, which is just the simplified way of writing 4 in 100. There are two concavities of vertical curves. The first one is summit curve, which is also called crest curves or over verticals. If defined mathematically, these are vertical curves where the total change in gradient is negative, but these can be simply defined as those concaving upwards. What are the gradient combinations to have summit curves? One is if both gradients are positive, but the first tangent is greater than the second. Example, tangent 1 is 4% and tangent 2 is 3%. Again, they are both rising up or positive. To prove the mathematical definition, we take the change of gradient, which is Q minus P. That is 3 less 4, which is then negative 1%. The other gradient combination has both positive and negative, where the positive gradient comes first as tangent 1, again followed by a negative gradient at tangent 2. For the sample gradients, the change is then negative 4 minus 4, which is then negative 8%. The other combination includes negative gradients. If the arrangement starts with a lesser negative gradient followed by a steeper tangent, say negative 2 and negative 3, the change of gradient is then computed as negative 3 minus negative 2, which is negative 1. From these three combinations, the change of gradient comes as negative, proving the mathematical definition. The opposite concavity of the curve makes it termed as valley curve, which is also termed as sag curve or under verticals. Mathematically, the change of gradient in this type is positive. There are also three combinations, and we start with the negative gradients. If two negative gradients are together, but the first is steeper than the second, for example, the first is -3 followed by -2, the change is -2 minus -3, which then becomes +1%. The other combination starts with a negative gradient followed by a positive gradient. Say we have -4 and +4 in this order. The change in gradient is then +4 minus -4, which makes +8. The third combination contains both positive gradients, where tangent 1 has lesser steepness but followed by a steeper gradient. In this combination, there are +2 and +3. The gradient range is +3 minus +2, which results to +1%. Lengths and distances in the alignment also have designated names, but we just tackle the basic elements here. With the curve from tangents or straights, there is PVC, which is short for point of vertical curve. PVC is the start of the curve. Next is PVI, or point of vertical intersection, where the two straights or tangents meet. At the end of the curve is another basic element, which is PVT, or point of vertical tangency. Designating labels for the horizontal lengths, the horizontal distance between PVC and PVT is L, or the length of the curve, where the length of PVC to PVI is L1. PVI to PVT is L2. Along the curve, there can also be POVC, or point on vertical curve. And across these points are POVT, or point on vertical tangent, which lie on either tangent. For vertical distances, the gap of POVC and POVT is also designated as Y, and the distance of PVI to the curve is labeled as H. According to their design, there are again two types of curves. The first one is symmetrical curve. These are those which are not really symmetrical, but then, when the horizontal distances are measured, symmetrical parabolic curves have the horizontal length from PVC to PVI as equal to the horizontal length from PVI to PVT. We can then say that the total length of the curve is equal to L1 plus L2. Let's illustrate this definition. Assuming that there are two tangents, the first is called back tangent, followed by the forward tangent. A highway is to be constructed, thus a curve is designed to connect them. The rising tangent has gradient 1, and the descending tangent carries gradient 2. As defined earlier, from PV1, the horizontal distance to the left is L1, which is equal to the horizontal distance to the right, which is L2. The vertical distance from PVI to the curve is H, and this is the same as the distance from the curve to the chord. There is also the highest point of the curve, and this is from S1 distance from PVC and S2 distance to PVT. The vertical distance between the highest point and PVC is then labeled as H1, and the counterpart is H2 from PVT. Then, taking reference from PVI, the vertical distance of PVC to PVI is A, and PVT to PVI is B. A is the algebraic summation of the gradients, thus G2 minus G1 due to the change of directions. One question that may make you wonder is how to get the highest point of the curve. With the same background as shear and moment diagrams from strength of materials, there is also a grade diagram in highway engineering. Instead of loads, use gradients. So positive g1 means there is an upward gradient which connects to the downward gradient g2. Note that the point of inflection in the grade diagram is the location of the highest point in the curve, which means the location can be solved through similar triangles or ratio and proportion. The other type is unsymmetrical curve. This is described as the vertical counterpart of compound curves. So there are multiple tangents. Say we have two tangents, and they are connected in a manner that a particular elevation at a certain station is required. From tangent 1, tagged as back tangent, a first curve is designed, providing another tangent, and then this is connected to another curve using the current tangent, intersected by a forward tangent. The point ending the back tangent is PVC. Then PVT also ends the curve. Then, the long chord is the connection of PVC to PVT. The horizontal distances using the first curve, and as measured earlier, the first curve has length 1, then from the first PVI, this length is then cut into half as this is a symmetrical curve. The connecting curve has length 2, and because this is also a symmetrical curve, from the second PVI, there are also lengths divided by 2. Now, the horizontal distance between PVC to PVT is still L. For the vertical distances, the distances of the partial PVIs to the curve are tagged as H1 and H2. The vertical distance from PVI to the curve is also labeled H, and also the curve to the chord. Next is to use the extended back tangent with the elevation of PVI. Using the gradient or the slope with the distance L2, we get the height as G1 times L2. The same thing with the triangle formed with the forward tangent. The vertical height of PVI with PVT is negative G2 L2. The summation of these two heights is then G1 L2 minus G2 L2. And when L2 is factored out, we get L2 times the binomial G1 minus G2.